Within a couple of months of a summer fire, the forest has more than recovered. It is rejuvenated. The fire has cleared away the old growth on the ground, and by reducing the pine needles to ash, has released their nutrients into the soil. And now the ground sprouts more flowers than at any other time. Because of regular fires, big bushes can't establish themselves here. So swampy areas are not colonized and sucked dry by them, as happens elsewhere. And open marshes remain where pitcher plants can grow and where frogs can swim and breed. Indeed, one species of frog lives nowhere else but in these pools in the American pine barrens. The woodpeckers here can't excavate their nest in dead trees as do woodpeckers elsewhere, for in this fire-ravaged forest they would risk incineration. So the red-cockaded woodpecker drills its holes in living pines. But the wood is so hard, it takes several woodpeckers about 2 years to dig the hole. Resinous sap seeps out around the hole where the outer layers of the tree have been breached. So the birds make their hole low down on the trunk, where the inner sap-free heartwood is thick enough to accommodate the entire nest. The flow of resin is diverted to the outside by drilling pits like sap wells above and below the hole. It's in these laboriously excavated holes that the red-cockaded woodpecker raises its young. The holes are very conspicuous, for each is surrounded by a sheet of yellow congealed resin. The rat snake is a great robber of nests and stealer of chicks. It's an extremely skillful tree climber. Since the woodpecker's hole in the living tree has to be fairly low down on the trunk, it is within easy reach of the snake and therefore might seem to be in considerable danger. But now the other function of all that resin deliberately produced around the nest by the woodpecker is about to become clear. The chemicals in the resin seem to irritate the snake beyond endurance, and it arches its body away. Eventually, it's too much. So fire, one way or another, influences the whole community of animals and plants in the pine forests of the south. This injury was also caused by fire, and this is also a coniferous tree, but a very different one. To start with, it's over 40 feet across along its base, and it's 267.5 feet high. This is a giant sequoia. It's thought to be about 2,500 years old. But the largest individual tree of all is this one, known as the General Sherman. It's just taller, and it's estimated to weigh 1,385 tons, and that makes it the most massive living organism in the world. Although these trees are growing almost as far south as the southern pines, the climate here, 2,000 meters up in the Sierra Nevada mountains, is much colder, and snow lies on the ground for almost half the year. It's as though by climbing to this height we have returned climatically to the great forests of the north. During the Ice Age, these sequoias grew over much of North America. But when, some 8,000 years ago, the Earth began to warm, they died out, except for these isolated groups high up in the mountains. We've travelled some 2,000 miles southwards since we started at the tree line near the Arctic Circle. And in all that vast territory, the majority of the forest trees have been conifers. So it seems only right and proper that we should end with these, the noblest of them all. As a group, the conifers owe much of their success to their ability to cope with the changeable northern climate. They can survive both the short, dark days of winter with their bitter cold, as well as the long sunny days of summer with their raging fires. But if we continue a further 1,000 miles southwards, we come to the tropics. And there, the climate is radically different. It's no longer very variable, but remarkably constant, with much the same amounts of light and rain and heat throughout the year. There, the other great group of forest trees, the broad-leaved trees, come into their own. That is the jungle, and that's where we will be in the next program.